Okay, one more function from 3.1. Again, problems similar to the ones we've been asked to look at in the past. Here's a function. Determine the intervals, find the critical numbers, determine the intervals where the function's increasing and decreasing, and then graph the function in your calculator. Well, I wanted to look at this one because it's just a little bit unusual. You know, if you go ahead and compute the derivative, okay, well, first of all, let's look at the function itself. It is a power of x squared minus 1. It's x squared minus 1 to the 1/2 power, right? The square root is the power 1/2. So to take the derivative of this, I can use that generalized power rule again. Okay? I bring down the power of 1/2, okay, multiply by x squared minus 1. Now the new power is the old power minus 1. So that's going to be negative 1/2. A half minus 1 is negative a half. And then I have to multiply by the derivative of what's inside the parentheses. So derivative of x squared minus 1 is 2x. Okay, now if you simplify this, what you're going to end up getting, I think these 2's cancel, and I'll get x over, okay, x squared minus 1 to the power positive a half, which I can write again as x over the square root of x squared minus 1. Okay, so this is the function. Now let's start talking about critical numbers. Okay. Now, the thing that makes this one a little difficult is that it's going to seem like there may be a lot of critical numbers and there really aren't that many. Okay, so the first thing we ask is where is, so that's the first step, find the derivative. Next we ask where is the derivative 0 and where is the derivative undefined. Okay. Okay, so let's talk about equal to 0. Where is this derivative equal to 0? Okay. Well, you know, as a fraction, you know, again, the thing to look at is when can a fraction be equal to 0? Okay. Well, a fraction can only be 0 if the numerator is 0. Okay. So, you know, perhaps this is equal to 0 when x is itself 0. Okay. Where is the derivative undefined? Okay. Well, let's look about that. Well, the derivative is undefined whenever the denominator, fraction's undefined whenever the denominator is 0. Okay. And the denominator is 0 whenever x squared minus 1 is 0. Okay? So that's going to happen when x is 1 or negative 1. So what I would do here is set the denominator, the thing inside the square root, equal to 0 and solve for x. Okay? Now it turns out this really is kind of more than the whole story and at the same time not the whole story. Okay? So in fact there are more points that will make the derivative undefined. In fact, the problem we run into here is that since we have a square root, this is undefined whenever the denominator is, when the term inside the square root is negative. So for instance, if you put a number like 0.1 in for x, well, you get 0.1 squared minus 1. Okay, well, that's, you know, it's like 0.99 or negative 0.99, but it's a negative number. So if we take the square root of a negative number, that's also undefined. Okay, so there's a little bit of a problem in here. There are many values of x that are going to make this undefined. In fact, if this is ever negative, we're going to get an undefined derivative, right? Because we'll be taking the square root of a negative number, and that's a no-no. Okay. Well, in fact, the way to round this, we don't actually have to consider all of those numbers that would make this denominator, the term inside the square root negative. Because really, if you go back to the original function, we can really start right here. What we need to do first on functions, you know, maybe not on paper, but think about it when we get to the critical numbers. What values of x is this function even defined for? Okay, because this is the square root of x squared minus 1. So when you see a square root, you should kind of get some alarm bells. And remember that, you know, square roots are only defined when the term inside is positive. Okay, so that was our derivative. But let's go back to the function for a second. You see, the domain of this function isn't every real number. Some numbers just plain don't work in the function. So if a number doesn't work in this function, of course, the derivative doesn't make sense either. Okay, we're not going to even be able to graph the function for x values where the derivative, where the original function isn't defined. So where is this function defined? Well, this function makes sense whenever x squared minus 1 is greater than or equal to 0. Okay, we're talking about the original function now. Okay, whenever this is greater than or equal to 0, I can take the square root and the function makes sense. Okay. Well, it turns out that this, you know, is x squared greater than or equal to 1, which means x is greater than or equal to 1 or less than or equal to negative 1. Okay, and you can kind of think about solving this using the technique from algebra for solving inequalities. Probably won't run into this problem very often, but In any case, this function is only defined for values of x bigger than or equal to 1 and less than or equal to negative 1. Okay. What does that mean? Well, if you look at the graph of this function, okay, there's negative 1, there's positive 1. There is not going to be a graph of this function between those two numbers because this function doesn't make sense. Okay. So what about those critical numbers again? Well, 0. 0 is not actually a critical number because the function itself doesn't make sense if x is 0. Think about it. If x is 0, I'd be taking the square root of negative 1. Okay, that's undefined. Okay. Now, in fact, these two are the only critical numbers, okay, because the original function does make sense if x is 1 or negative 1, okay, and our derivative is undefined, definitely for those two values, okay. So our function can change from increasing to decreasing at just those two numbers, negative 1 and positive 1. Okay. Now when we go to think about our intervals to test, remember the main goal in this problem is to figure out the intervals where the function is increasing or decreasing. Okay. Intervals are going to look a little different this time. The test intervals, okay, they're going to be from negative infinity to negative 1. Okay. And then from 1 to infinity. Notice how I skip everything between negative 1 and positive 1? Well, of course I skip it. The function isn't even defined, so the derivative is nonsense between those values. So I just need to look at these two intervals. Okay? And if we test those, what we'll see is probably not so surprising, but I think in this case the derivative is going to be negative. If we put a number like negative 2 into the derivative, you'll see that the derivative is negative. Okay, so f prime of negative 2 will be less than 0. F prime of a number like positive 2 will be greater than 0. Okay, so the function is going to be decreasing on this interval, increasing on this interval, and doing absolutely nothing between them because the function isn't defined. So if you go to the calculator, type this function in, type it like, of course, x squared minus 1 to the power 1/2. You can graph that on the calculator. In the graph you'll see it looks something like this. Okay, calculator might have a little bit of a trouble in graphing near these points where it's undefined, but there is no graph between negative 1 and positive 1 because the function itself doesn't make sense.